We can't hear you, Luis. Nope. Nope, we can't hear anything.
No, we can hear each other, but not you. You look good, but we can't hear you.
You look nice and warm.
Well, maybe your headphones are broken.
I did ask a question on the message board. I haven't gotten a response yet.
And what was the question?
Well, when I watched the video over the preparation, he kept talking about the, what's it called?
Hey.
Some kind of number that's supposed to be 4 times as large.
Yes, the variance.
The variance. But on the video, he keeps saying 2 times the variance. That's just incorrect, right? Like
he was saying, I think he was saying that the variance is the standard deviation squared. But if he said 2 times the variance, he was wrong, because it's 4 times. So the largest variance has to be less than or equal to 4 times the smallest.
The smallest, right? Okay.
So I think he was either misspeaking or something. So.
Yeah. Okay. Well, he was writing it up on the board and everything. So I was like, maybe I missed something.
Oh yeah. No, I didn't see that guy. I didn't see that dude. So, yeah. All right. Are we ready to start? So Tyson, we can't hear Luis tonight. His microphone is broken.
Okay. But he can hear us, so that's good.
Yeah, he can hear us. So he's just not going to be reading tonight. So.
Okay.
And I have to leave right at the 30 after.
So we are going to get right to it.
Yeah.
All right.
See if we can get through.
Okay. So do your first 2 answers. Yes, yes, or true, true, or whatever it is.
All right, I'll go ahead and start.
Sure.
Well, you are required, oh, whoops, we already know all that. Okay.
Yeah.
In an ANOVA hypothesis test, we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. And that's true.
True. Yeah. Good.
What requirements need to be checked when performing an ANOVA hypothesis test? Sample means are all positive. Data in each group are normally distributed. And variances are equal in each group. Okay, I know that the data has to be normally distributed.
Yes.
Yeah.
And it all has to be positive too, right?
I think so, because it's that one tail, and it says it's always that the F or whatever is always positive. So
it was right skewed for sure.
Yep. And then,
but the variances don't have to be equal, because you have to judge.
But they do. What they're saying is, if we judge if we use that formula, that tells us that the variances are equal.
Okay.
I know it sounds
enough, I guess.
That's what I
equal
think.
So that they fall into some kind of parameters.
Yeah, let me I have my textbook something. I want to look at the chapter. You can go on. I just want to look at the chapter.
Okay, for now we'll go ahead and mark that one true. I mean, you know what you're doing, Susan. So like,
but sometimes
okay,
birding or something, you know.
Yeah. Okay, to check if each group is normally distributed, do the following. It's the QQ plot, right?
Yes.
Or they say histogram too, right? Or the histogram just kind of helps you.
Well, I don't know. I think
I can't really understand the histograms too well. So
I think it's the QQ plot, because a histogram can look all weird, but I think the QQ plot is the one that's really going to tell us.
Okay.
Let's see.
We assume that the variance in each group is the same if the following happens. It's the largest variance is less than 4 times the smallest variance.
Mhm.
Yes. And looking back at the solutions for the preparation, here's what it
Yes.
says. The rule is if the largest variance is not 4 times the smallest variance, then we conclude that the variances are equal. So that's
Okay.
why
Okay.
but see how it's worded here. It says variances are equal in each group. I don't know if,
Yeah.
you know what I mean? That's weird language.
Yeah.
Well,
I guess that's one we can take a chance
yeah, let's
on.
mark it to, let's mark it true, and then we just might need to change that one.
Yeah, okay. All right.
All right. So then number 6 is B, largest variance is less than 4 times the smallest variance.
Mhm.
Yes.
Number 7, an ANOVA hypothesis test is equivalent to conducting independent 2-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs, 1 and 2, 1 and 3, and 2 and 3. How many pairs are there with 4 samples?
I believe there are 6. Because it's 1, 2,
1 and 2.
1, 3, 1, 4.
Mhm.
Then we go to 2, 3, and 2, 4.
2, 4. That's right.
And then we
And
go
then
to
3, 4. Yeah,
Right?
6.
So
Yeah, I think
6.
so.
Mhm.
Yeah, I think so. All right. Sorry,
Luis,
Luis.
he's still with us. He's got his fingers up.
Okay, good.
All right.
Okay, I'll read this information here.
Okay.
The data in soccershoes.xlsx was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes labeled A, B, C, D, E, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. Okay. So question 8, what is the minimum or smallest variance for the 6 group? So we're going to have to
I'm getting the data in.
download the
Yeah, me
information.
too. A lot of data.
Mhm.
Uh-huh. So as you're doing that, I'm reading in the textbook where it says requirements of ANOVA. And it says there are 2 requirements of ANOVA that must be checked. 1, the data are normally distributed, which we check, it shows, and the variances are equal for each group. But it doesn't say the positive, although when we read the chapter, we learned that they're always positive. So I don't know if we are to put that or not as a requirement. You know what I mean?
Yeah.
So I do feel good about that equal, the variances are equal. But I guess it's one we're just gonna have to try and see
Yeah, well,
on the other one. Okay,
So I got 27.208.
me too.
I'm sorry. Okay, so what are we looking for? The minimum.
The smallest variance of the 6 groups.
Yeah, 27.358. Oh no, 27.208.
Oh,
Yeah.
Yeah, okay, I got that also.
and the next question asks for the largest one. So that I have 53.158.
Yep.
Is that what you all have?
Mm-hmm. Yes.
0.158. Okay. The next question is, the test for equal variances is satisfied for these data, true or false? I believe it's true because the smallest one times 4 is larger than
Mhm.
the highest. So,
Yeah. Okay.
Yes.
oh geez, now we have to construct a QQ plot for each
Oh,
of the 6
nice.
samples. Why don't we take different ones? Because you have to put them in one at a time.
Mhm.
So I'll take the first 2 since Luis can't talk to us. I guess he could give us a thumbs up or something. Luis, you want to take the last 2? Can we see him? Where is
Let me
he?
see. Yeah, I think he says that's fine. Yeah, that's good.
Okay, so he'll take the last 2. I'll take the first 2. And
Where do you
Lisa,
go
you
on
take
these?
the
It's
third.
the
You have to
you have
Go
to
ahead.
open up that first spreadsheet that we had with the
Oh,
Z
yeah.
score and all
Okay.
that.
And put them in there. That's right. Okay.
Yeah, it's one of the tabs.
So Lisa, you take the third one, and you take the
Okay.
4th one, Tyson.
Okay.
So Tyson has D, Lisa has C. I'll do A and B, and Luis will do the last 2. So we're just looking to see if they're normal. Remember to sort.
Yeah, I was
Smallest to
gonna
largest.
say it always
Okay.
looks bad until you sort from
Yeah. So
smallest to
A is
largest.
fine.
Okay.
So the first one is fine. Let's see.
How do you sort it?
Up
You
there at
click
the
on
top,
sort and
Oh,
filter,
okay.
there's a little
I see.
AZ.
and then
Smallest to largest.
B is okay. B is distributed normally, kind
Yeah,
of.
so
I mean,
let's
it's
see.
yeah.
Yeah, C is good.
Sorry, did I do the wrong one?
That's okay. I'll do D real quick.
Okay.
How about you, Luis? Did you get your 2? Are they okay? They're up. Thumbs up. His are fine. So I have a feeling they're all fine, right?
Yeah. Yeah, D is fine also.
Okay. So that would be true. Okay, question 12. Perform an ANOVA test in SPP. We don't have SPP.
No.
And observe that the p-value, but that's okay. We did it in Excel, right?
Yes, he said
Yeah.
something about that. I listened to one of his office hours today, and he talked about how next semester everybody's going to be on Excel.
Oh, good.
Okay.
'Cause-
But this SPSS whatever is supposedly a lot more powerful software,
yeah.
but the Excel is more readily available or something. So
Well, and probably for what we're going to do ever in our lives, it's probably fun.
yeah.
Okay, so it says observe that the p-value is 0.081. So is that what it is? I'm not looking at it right now.
Yes, it is. It
Yes.
is.
Then remove the SOX data and perform the test again. So the last column, 6, and then what is the p-value?
0.309 is what I got.
What's the best way to clear this out? Am I like missing something? Because sometimes if I hit, I don't know, I hit different things and then sometimes it gives me skewed numbers because I have zeros in there instead of.
Oh,
I
I don't
just-
know. I just go in the top one and do Shift Control and press the down arrow and press delete. So
Delete.
Yeah,
Okay.
I just, yeah.
Okay.
yeah, I have 0.309 as well.
Yes, that's what I have to.
I'm guessing, Luis, you do too. Okay, question 13, and then I'm done. The test statistic for an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or left of the F statistic? It's to the right, correct? It's in the right tail.
Yeah, it should be.
Is that? And one of the things, they kept showing that in the book, and I thought, well, is there one we can use? But I never found that there was some F statistic chart like the T value
Like
and the
an
zero, you know.
Yeah.
So do we agree on that? That the F statistic, the P value is always in the area to the right? Yes. Because I'm looking at it in the book right now.
Okay. I was gonna say I don't remember that.
Yes,
I need
it
to
is.
read up on that.
It's always in that little tail. So, and that's to the right. Okay, somebody else now. Tyson, I guess you.
Yeah, I'll take it.
Oh, the hot dog.
Okay. Researchers at Consumer Reports analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, but up to 15% poultry meat. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. Their
That's just
data
gross.
is in the file. Okay. Yeah, that is gross.
I
Yeah,
don't like hot dogs.
I love hot dogs, and I just close my eyes and eat them. So
Me too. Yeah,
Don't
me
read the back of the package.
the old byproducts, you know,
Yeah.
toenails and you know.
Everything else, nobody else wants to see that they're eating.
Yeah. So we're supposed to
Except
do
the hot dogs.
So,
What are we supposed
yeah,
to
we're
do
doing
here?
more QQ plots. And
the calories.
yes, for the calories first, it says construct QQ plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
All right.
All right.
I'll do the meat ones.
Okay, I'll do the.
Oh, you got really echoey all of a sudden.
Yeah.
Is that me? Oh.
Sounds like we're in a space movie. Louise?
There we go. That's better.
I'm sorry, can you hear me now, right?
Yes,
Yeah.
yes.
Yeah,
You.
it's
We're not in
me, it's me. Yeah, I'm the guy with the troubles today. So, yeah, can you hear me? Can you hear me now? Well,
yeah,
right?
it's
Yes,
good
we
now.
can.
Yeah,
Perfectly well.
I'm using my iPhone. So
Nice.
Oh,
Oh, good.
all right. I'm doing beef calories. Beef calories
Calories.
for the QQ here. Let's see. Beef calories for QQ are normal.
Okay. I'll do poultry.
Yeah, I'm gonna have to leave in about, I don't know, 5 minutes maybe. So
Okay.
I may not be able to finish with you guys.
I think this one is pretty normal. I mean, it comes off the,
Yeah,
if it comes off a little bit in a curve, it's okay, right?
yeah, I think
As long as
so.
it's not just way out there.
Yeah, I think so. There's no outliers or anything. Because there was one when I was doing a practice that looked fairly normal, but I didn't notice there was one outlier, and that's, it said, nope, this is not normal. So,
Gotcha.
Looks like this is normal as well. So
all right, so now I think we have to put these into our regular inference thing. Oh,
So we
clear out-
clicked the first one, right, for 14?
Well-
The assumptions have been met. It's safe to assume each group comes from a normally distributed population.
No, because we now have to check the variables to see if they're equal.
Oh,
The
okay.
variances, that's right.
So let's just quickly put those in here. Make sure the variance isn't. Oh, crap. Sorry. I don't like doing all this cutting
I
and
know.
pasting.
Yeah,
Mhm.
and deleting.
Mm-hmm. All right, 1. Two. Three. Oh, they're fine.
different.
Well, they're different, but they're, so
That's
like
okay.
I have 512, 636, and 508. But is that what you guys have?
Hold on.
512, 636,
Yeah.
and then I'm working on the next one.
Okay. So they are equal because they're within 4. Small times 4 is less than
Mhm.
large. So they're equal. So it's yes, I guess, is the answer to this question. Oh, so we have to say the assumptions have been met. Population Q plus.
Yeah,
Yeah, so I think it's number 1, right?
the variances are equal.
Yeah. So the
So
third
see,
one I
that's
got
why I
508.
Yeah.
Okay.
Yes.
Yeah. So that's why I think when we go back to that other question, we're only going to choose the 2 things, the normally distributed and the variances are equal. I don't think we're going to put that positive number, even though I believe it's true.
Okay. Because it's not something that we have to actually measure. It's just something that happens.
Right. That's what I think.
Mhm.
I'm going to do that. So who knows?
Okay.
What'll happen. Okay. What's the next?
Okay. 15 says, run an ANOVA test to determine if the mean number of calories is the same for all 3 types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and that P equals 0 with a level of significance equal to 0.5 or 0.05. What conclusion can you draw?
So they told us the answer to that, right?
Yeah.
So the P is lower than the level of significance. So we have sufficient evidence to claim that all 3 hot dog that at least one of the hot dog types has a different mean number of calories, right?
Yeah, that last one.
Yeah.
Yes.
Because you
It's the
don't know
first
if
one.
it's all of them. It's just one at least. You
Yeah.
don't know which.
So